Little did Kaichang Li know, as he searched for crabs with a friend along the rocky beach at Newport on the Oregon coast in the United States of America, that this day was going to change his life. Despite their searching, the two friends didn't have any luck finding crabs. But as he was wading in the surf, Kaichang Li spotted the exciting new glue of the future. Beneath the surface of the water, a group of blue mussels were anchored to the slippery rocks, clinging tight against the turbulent waves. Having failed to find any crabs and determined not to leave the beach empty-handed, the two friends sat down amongst the rocks and instead tried to collect some mussels. Li, who is a chemist at Oregon State University, was amazed at how much strength and effort was needed to pull the shellfish off the rocks. In fact, the men failed to pull any of the mussels off the rocks by hand and had to use a large piece of driftwood to prise some of them free. Whilst his friend took a share of the mussels home to eat, Li took his portion back to the lab, eager to find out how these creatures achieved their remarkable grip. The blue mussel, also known as the common mussel, is a medium-sized bivalve, meaning it has a hinged double shell. It's about 10 centimeters long and 5 centimeters wide. Its shell varies in color from purple to brown to blue. They're found widely, including along the Arctic, North Atlantic, and Baltic Sea coastlines. The best places to look for them are on rocky shores, where they're attached to the exposed rock and in crevices, as well as on piers in sheltered harbors and estuaries. They may all look alike, but there are different sexes of males and females. The adults reproduce by releasing sperm and eggs into the water to be fertilized. As you can imagine, this is all a bit of a hit and miss affair. And despite far greater numbers of sperm being released than eggs, many eggs are not fertilized. Mussels are described as being semi-sessile. This means they're able to detach and then reattach to the surface so that they can reposition themselves as and when the water levels change. Dense masses of mussels attach themselves to surfaces by what looks like a beard. This beard is made up of 50 to 100 individual threads called byssus threads, which are produced by a byssal gland inside the shell. At the end of the thread is a small adhesive plaque, and it's these which the mussels use to cling to different surfaces. The surface or cuticle of the thread is as hard as the epoxy resin or adhesive used to manufacture printed circuit boards, but it still has the ability to flex and extend. The juvenile or young mussels, which are less than 2 centimeters in length, can use their byssal threads like climbing ropes, extending, attaching, and pulling themselves forward. Matt Harrington and his research group at the Max Planck Institute of Colloids and Interfaces discovered that there are separate glands responsible for the adhesive plaque at the end of a byssal thread, for the core and for the cuticle. But what really fascinated Li when he began researching the mussels was that these threads are made of proteins. The mussels stick to the rocks through strings of proteins. Proteins are made from building blocks or ingredients called amino acids, and the composition of these amino acids was unique. A good adhesive must be strong, of course, but also flexible, and the mussels had evolved a perfect solution. But what also impressed Li was that he didn't know of any other type of adhesive that could work as well in water and withstand so much force. For Li, this was a eureka moment. Could he use this knowledge to make a super sticky glue?
If you're enjoying this video, make sure you hit that like button. Liking the video does wonders for the channel and helps to spread this video to more people just like you. And if you're a fan of nature-inspired solutions and success stories like this one, 30 Animals That Made Us Smarter, the book, might just be for you. Check out the link in the description to order your copy now. All right, let's get back to the episode.
Now, whilst Li was thinking about his mussels, Steve Pung, the Vice President of Technology at Columbia Forest Products in the United States, was thinking about his hardwood plywood. Hardwood plywood is made of several thin sheets of wood that are glued together. The result is a versatile and highly workable material. This layering of thin sheets of wood gives it strength and flexibility. It's the sort of thing that's often used to make the doors and sides of cupboards as well as floors and walls. As you can probably guess, there's loads of it about in homes, schools, stores and offices. Well, Steve had a problem. He was concerned about the use of formaldehyde in products produced by the company. The reason he was concerned was because there was growing evidence of a link between formaldehyde and cancer. Steve and his colleagues were eager to find something that could replace the formaldehyde in the decorative plywood produced by the company. Back at Oregon State University, Li was having tofu for lunch one day, and it got him thinking about soybeans, as these are used to make tofu. He remembered that soy contains about 50% protein. So then he wondered excitedly if he could convert the soya protein, a renewable natural resource, into mussel protein to create an effective adhesive. He was keen to find out. He compared the chemical structures of soy protein and mussel protein and invented a glue by mixing the soy flour and a curing agent in water. A curing agent is a substance which is used to harden a material, and the curing agent that Li used was already commonly used in paper towels and tissue paper. The plywood he made was very water resistant. And to demonstrate this, he boiled samples of plywood and then dried them in the oven, and they didn't fall apart. As many of you will know, wood swells when it gets wet and shrinks when it gets dry. This swelling and shrinking created a lot of pressure on the glue when the plywood was boiled and dried, and yet the new glue remained water resistant, just as the mussels remain attached to the rocks as they're soaked and dried by the sea and the sun. As Li explains it, the adhesive penetrates the wood fiber and locks it in place, like a key in a lock. When he was happy with the result, Li gave a presentation about his work, and guess who was in the audience? Steve Peng. Steve couldn't quite believe his ears. Here seemed to be the answer to his problem, an answer which he'd been looking for years. So given that there's no time like the present, Steve immediately got to talking to Li after his presentation, and before he left, they'd struck up a deal to pursue commercialization of Li's adhesive. This was in 2003. Work began in the lab, first using a portable mixing system, and then Li and his team went to the factory and tried it out. But the first trial was a disaster. Nothing worked. Now, Li might have given up there and then, but just like the mussels which had first inspired him, once he got attached to an idea, there was no letting go. And so, like any good chemist, he returned to the lab, reviewed what worked and what didn't, and tried again. And very soon, he found a solution. In 2005, Peng's company had started converting their mills, and by 2006, the company had converted all of its plywood plants away from formaldehyde-based adhesives to this new soy-based glue. In recent years, the regulations about formaldehyde use in plywood and other wood products have been tightened, and many other companies have converted to using a soy-based resin as the bonding agent. Just think, if Li had caught some crabs on that day on the beach, he might never have stumbled across those mussels and discovered their tenacious grip, or known the impact he'd have on hardwood plywood production.
If you enjoyed this video, make sure you hit that subscribe button and head to the comment section to share the ingenious ideas that you've come across too. For our offers and much more, head to the episode description below. And if you're looking for more great content, then check out this next video. Thanks for watching.